let us integrate sine inverse of x. In some textbook they also call arc sine. So sine inverse of x dx. So we're going to use the integrating by parts method. So here what I've done is I've written this as sine inverse of x times 1 dx. Okay, so I will let f of x, the first function, to be sine inverse of x, and the second function I have let as g dash x. So this is a gradient function and this is a function. So now to be able to differentiate this function, now the differentiation of this, if you know it's good, but let us differentiate this. So writing, if y is sine inverse of x, I can write x is sine y, and differentiating both sides with respect to y, d by dy of x is equal to d by dy of sine y. Okay, d by dy of x is nothing but dx by dy, and d by dy of sine y is cos y. Okay, now I take the reciprocal of both of them. So dy by dx is 1 over, because here this is cos y over 1. So this will become 1 over cos y. And therefore, and cos y is square root of 1 minus sine squared. So we have used the identity sine squared x plus cos squared x or cos squared y. We are writing in terms of y, so I can say cos sine squared y plus cos squared y is equal to 1. So cos y is square root of 1 minus sine squared, and what is sine y? Sine y is nothing but x. So I can write dy by dx is 1 minus 1 over square root of 1 minus x squared. So this is a good formula to remember, that the gradient or the derivative of sine inverse of x is 1 over square root of 1 minus x squared. Or also, if you integrate this, you get sine inverse of x. Okay, so I have rewritten the whole thing again. So if f of x is sine inverse of x, f dash x is 1 over square root of 1 minus x squared, and when you integrate this, if g dash x is 1, g of x is x, or conversely, if g of x is x, g dash x would be 1. So now this is the chain rule, sorry, this is the integrating by parts formula. Integration of f of x times g dash x dx is equal to f of x times g of x minus integration of f of x, f dash x times g of x dx. Now it's an easy formula to remember. What you do is you integrate this line, this times this is equal to the product of this two. The product of this two minus the integration of this line. That's what I've done. That's how I remember. Okay, so I'll just substitute the values. So f of x is sine inverse of x times g of x is x minus integration of f dash x is 1 over square root of 1 minus x squared times x dx. Okay, now to integrate this, I've done, let me remove the veil. So I want you to look at this side. So I have let this the term inside the radical as t. Okay, so 1 minus x squared is t. So minus x squared is t minus 1. So x squared is 1 minus t. So t is 1 minus x squared. I could have deleted. There was no need to write this step. Okay, so whatever. So t is equal to 1 minus x squared. So now differentiating with respect to, or applying the derivative operator, d by dx of t is equal to d by dx of 1 minus t squared, 1 minus x squared. So d by dx of t is nothing but dt by dx. The derivative of 1 is 0, and the derivative of minus x squared is minus 2x. So cross multiplying, you can say x dx is nothing but negative half dt. So in place of x dx, we can put negative half dt. So in this is why in place of x dx I have to put a negative half here. So this is negative half dt. And this negative and negative becomes positive, and that's why I put a positive here, and I factored the half out, and this becomes t to the power negative half. And so this I have to write a half here. So this is integrating t to the power negative half would be, we have to add 1 to this, that will be t to the power half over half, and this half becomes, this is 1 over 2, 1 over 2, and this becomes 2 times this 2 will go to the numerator. That's how, and then this and this gets cancelled. So finally you get x times sine inverse of x times plus square root of t plus c, and t is nothing but 1 minus x squared. And so this is the integration of sine inverse of x is x times sine inverse of x plus square root of 1 minus x squared plus c.